Hey, good morning, everyone. Welcome back from break. My name is Matt Miller. I'm part of the program committee for Authenticate 2024. I got a wave. Can't hear? I don't know if this is on. This is on. Okay. Hey, how about that? Hey, good morning, everyone. Welcome back from break. My name is Matt Miller. I'm part of the program committee for Authenticate 2024. I want to introduce our next speaker. He's the senior standards dude at Okta. Give it up for Tim Cappalli and peeling back the Passkeys onion.
Thank you, Matthew. All right, hi everyone. Thanks for joining this session. A little bit about me. You may remember me from Microsoft. I was working on Passkeys at Microsoft. Went to Okta since the last Authenticate. Socials, you can find me online at timcappalli.me. I live in Boston, work on standards related to digital credentials at Okta. So not just Passkeys, mobile driver's license, verifiable credentials, all these fun, new and innovative technologies there. Matt and I also maintain Passkeys.dev and also the digitalcredentials.dev, which focuses on mobile driver's license and verifiable credentials. And I also love to take pictures, so got to throw a quick picture of Boston in there, best place on earth. So we're here to talk about passkeys and layers. Everyone's seen Shrek, right? Ogres have layers, well, passkeys have layers. So we have a couple of topics to talk about. We'll do a quick refresher on terminology. We'll go through the different flows that are involved with passkeys. We'll talk about the different players that are involved, the different layers. I couldn't rhyme again, and then Q&A. It was fun to have two rhyming. Quick disclaimer. When I first did an outline for the session, it timed out to an hour and a half, and we have 20 minutes. If you are very technical and familiar with passkeys, you're going to probably be like, but yes, you're right. I had to trim out some things. I had to summarize some things. I'm not able to cover everything. But the goal is to highlight the most major and most impactful layers that really play here for operational interactions, the way users perceive passkeys, the prompts they get, all those fun things. But there are steps and interactions that are omitted. We're going to actually completely skip one whole big part of this because of the time crunch. So let's do a quick terminology check. So the web platform. The web platform is essentially the platform that is the browsers, right? Many folks don't consider the browser a platform, but it is. It's arguably the largest out there. It's browsers, web views, PWAs, anything that runs like a web technology is considered the web platform. Combination of JavaScript, HTML, CSS, all that fun stuff. That's where WebAuthn operates. The app platform, so that's where the browser runs, essentially, right? So it's the underlying operating system, it's platform APIs, right? So Android, iOS, macOS, Ubuntu, Windows are the popular named ones, and all the fun different variants of Linux. The WebAuthn client, right? So this is a term in the WebAuthn specification. Most simply, it's the entity implementing the WebAuthn API. So it's responsible for dispatching requests to the authenticators and returning the response back to the website known as the relying party. Typically, web browsers implement the WebAuthn API, but also you have to think of these native APIs that exist on the platforms as an abstraction around the WebAuthn API, which also makes them a WebAuthn client. Names for providers, right? This is a mess, like I'll admit it, like as one of the people trying to drive some of these terms, but credential providers, passkey providers, authenticators, they're all logically the same thing. They're the place that you store your credentials, right? The thing that hold them. They're wallets at the end of the day. Let's throw wallets in, right? They're all the thing that users store their credentials in, whether they're passwords, passkeys. In the context of today's discussion, they're passkeys. And the last term, authenticator selection. So I'll refer to this a few times in the talk. This is that screen that you get that ultimately shows, like, where do you want to store your passkey, or where do you think your passkey is, or where do you want to select? So we generally refer to this as authenticator selection. All right, let's jump into the flows. There's two major flows in WebAuthn and with passkeys: registration and creation, and authentication. Registration and creation, generally speaking, has a higher cognitive load than authentication because the user ultimately has to decide where they want to put something. Now, for users that only have one authenticator, like they just have a default, a device that's just set up by default, it only has, let's say, Windows Hello or iCloud Keychain, maybe it's not as high of a cognitive load, but users that maybe work across ecosystems or have multiple different devices not made by the same vendor may have more selections during a registration phase than they do during authentication. So I hope by the end of this session, it'll be clear why authentication is a little bit more simple from a user experience standpoint than registration maybe. The different players, right? The 4 core players here are relying parties, right? So that's the website that's asking for a sign-in or asking to create a passkey. The browsers, right? We're mostly going to talk about the browser context today. The OS platform, because ultimately the browser has to talk to the OS platform. It's running on that OS platform. And then the authenticators, where you're actually storing the passkey. Passkey provider, credential provider, authenticator, whichever of those terms you want to use. And there's a bunch of well-known names that fall into those different categories. Relying parties, probably everyone in this room is a relying party in some context. There's 4 major browsers plus all of the different forks of Chromium and Firefox and Gecko and all those fun things. 4 major OS platforms, Windows, all the Apple platforms, Android, and Linux. And then a bunch of authenticators, right? You'll notice I have a mix of icons there, right? Some are traditional security key vendors, which are also passkey providers in the general context, all the way over to, let's say, an enterprise passkey provider that stores device-bound passkeys, right? So that's the 4 major parties, right? And that's it. That's the end of the story. No. So this gets complicated, right? Some browsers have built-in providers, right? Chrome has Google Password Manager built in. Firefox has, I don't think they brand it, but a password manager built in. And there's also browser extensions, right? So browser extensions are not necessarily running, they do not run at the OS level. They run in the browser context to make themselves available to the DOM in the browser, right? So these 2 things alone throw a kink in that four-party model here. So let's look at the layers of how these all come together. These diagrams are deliberately like a little much because it is fairly complicated here, right? So we talked about the relying party. I don't think I have a laser pointer, but so we talked about the relying party, right? The relying party is ultimately rendered into the browser when the user loads a page. The browser is sitting on top of the app platform, which then is on top of the OS platform, right? So in this case, the relying party is talking to the browser via the WebAuthn API. That's those green lines. Then the browser ultimately needs to now talk to the OS platform somehow. That's typically not publicly, it's not a standards-based interaction. It's, on Windows, it's going to be the Windows APIs. On Mac, it's going to be the Apple APIs. And then ultimately, what if I need to actually talk to another platform across on my other devices, right? Maybe that's my phone, maybe it's a tablet, and I have that same kind of loop back through the local app platform and up to the app platform APIs. Now, as I mentioned, the extra parties I got added here is not only do I have passkey providers that live at the OS level, I also have them pinned to the browser, right? So my browser, let's say it's Chrome, I have Google Password Manager. On the app platform side, if I'm on Mac, I have the Passwords app, formerly known as iCloud Keychain, and the same thing could happen on my phone. So I may have, deeply integrated credential providers in the browser. I may have an externally installed via the App Store, and then there could also be a browser extension, right? So this gets really, really complicated. And let's not forget the original passkey provider, the security key. They're also in this picture, and now I have to be able to interact with a security key, right? So this is super easy, right? Like this is not a problem. This is everyone understand this, right? So I got to have for Megan, little Taylor, right? It's me. Hi, I'm the problem. It's me, right? So this is essentially what we're talking about today, right? This is complicated. It's not done, right? A lot of this work is still happening, and so let's dig through some of these touch points that interact with these experiences. So the one that we are not going to dive into deeply because of time is registration and creation, but I did want to give a summary of all the different kind of inputs and ways you can influence the registration experience for Passkeys. So the first is hints. Is anyone familiar with hints? It's brand new. Okay, a few people. So the idea with hints, one of the pieces of feedback as Passkeys rolled out was, especially for workforce, I'm an organization that is only ever going to deploy security keys. Why am I getting all these prompts that have nothing to do with security keys? So the idea with hints is you could say, hey, like during this registration flow, please guide the user first to security keys. Now that's not going to mean that the client isn't going to say, hey, like you can still dump out to cross-device or these other flows, but like the first thing the user sees, I want it to be security keys. All right, so that's the most influential first touch point for the registration experience, and it's slowly rolling out to clients over the next few months. The next one is authenticator attachment. This is one that's been in WebAuthn for quite some time. This is just platform or cross-platform, right? Do I want to create the passkey locally on the device, or do I want the platform to force it to be cross-platform? Now, this one is a little bit more of this one is not a hint, right? You notice the first one is called a hint. The client can still do what it thinks is best for users, Because at the end of the day, that's the client's role. And I hope by the end of the session that will be clear, right? The client's goal is to guide the user to what it thinks is best. But the authenticator attachment is a command, right? It's like you will only create this credential on a cross-platform authenticator, right? So that's why if you've ever played with this, there's generally not a lot of leeway in the UI if you select cross-platform versus platform. The next one is an exclude credentials list. So this is to say, hey, these are all the credentials I already know about. If you come across this, don't create another one. Don't override it. Don't do that, right? That's how you get this experience where, hey, you already have a passkey, right? You don't necessarily want to override the passkeys that are in there. Then we kind of shift away from the spec and into client implementation, right? So many clients out there, like Chrome is a great example. Chrome will actually remember what is the last authenticator you used, right? So it'll slowly start to understand, like, oh, well, if I have Google Password Manager and iCloud Keychain available, and I'm always selecting Google Password Manager, maybe I should just show Google Password Manager by default and allow the user to escape out of it if they want to. So that's more of that's an example of shifting from very prescriptive things in the spec towards the client trying to help the user based on what the client observes, right? So recently used is very, very common to help the user to the right place. And then the last one is showing the authenticator selection screen, right? So in cases where maybe you don't know, maybe this is the first time the user has used a passkey, you don't know which they selected, that's going to show that authenticator selection we saw in the terminology section. So here's a great example of the result of that, right? So in the case where I've used, let's say there's a case I have not selected, I have not selected Google Password Manager before, I have not selected iCloud Keychain, I'm probably going to get this very busy dialog on the left for the first time, right? I can use Google Password Manager, which is going to save them with my work account to Okta. I can save them to my iCloud Keychain, which also may be a work account, or I can save it to my phone or a security key, right? Now, in the case where I actually did start using Google Password Manager, the next time I come in, I actually might be taken directly to the screen on the right, which is like, okay, we think you've been using Google Password Manager for a while. Why don't you just save it to Google Password Manager? And if you don't want to, you can click Save Another Way. Right, so this is an example of the client becoming more and more helpful to the user based on their behaviors and how they've been interacting with the system. So let's shift over to authentication. Authentication is designed to be much smarter, right? The client has more context, and this is really where the WebAuthn client shines, right, in helping the user sign in quickly. So the first thing that gets looked at is the allowed credentials list, and we'll dive into each of these individually. Then it will look for local passkeys, and then it will fall back to us external authenticators. This is the example that I mentioned, like I'm cutting a lot of steps out here for the sake of time. There's other things that happen, but these are the 3 core touch points. How many people are familiar with allowed credentials? If you've been doing FIDO a long time, you're probably very familiar with it because it was very popular before Passkeys. So the idea here is if you already know something about the user, you can send an allowed credentials list, essentially telling the client, these are all the credentials I will accept for the user. Right? So this is very, very common in like second factor flows where you have a username and a password. Obviously, you know who the user is. You can send and say, like, these are the following credentials that I will accept. It can optionally include transports. And transports are essentially for, like, let's say a security key that is available via USB, right? You can say USB. Or for a platform authenticator, for a device-bound passkey, it may only say transport internal, meaning it's only available on this device. With passkeys, right, so as I mentioned, this was heavily used in the 2FA kind of legacy model. With passkeys, this is typically only used now with re-authentication scenarios, right? So if I am signed in, GitHub uses this, for example. If I'm signed into GitHub and I'm going to delete a repository, ask you the scary, type in the repository name, and when you click delete, it's going to say use a passkey, and they actually send an allow list and say, because I know who the user is, I'm going to actually say these are the only credentials that are allowed. And you can tailor that list based on the login session, right? So let's look at a real allow list. So this is, there's 3 credentials in this list. The first one is most likely representing a synced passkey provider. So Dashlane, 1Password, Bitwarden. And because the transports are hybrid internal, meaning it's available cross-device and on the local device. The second one is most likely a security key because it's USB, self-explanatory. And the third one is most likely Windows Hello because currently Windows Hello is device-bound and it only has internal. Right, so I have 3 different credentials with different experiences that will result, and I can tailor this experience, right? So if I wanted to say, if I'm on Windows, and I know that the user used the credential with JWCA to sign in to the session 30 minutes ago, and it's the same login session, sessions are typically device bound, I can actually send an allow list with only this credential ID at the bottom to then make sure that the user is only prompted directly for Windows Hello and doesn't have to go through a selection screen. Right? So these are examples of how you can tailor the user experience depending on the flow that you're in. So on the left-hand side is a sign-in flow without an allow list. Right? So this is your typical sign-in with a passkey flow. I'm on a login page, and I click a button, sign in with a passkey. And because there's no context, you're going to get a selection screen, right? So in this case, it's saying, hey, you have a passkey for Amazon.com. For this user, that's the only one you have. So we think you want to use it. Just click continue, and you'll do the bio prompt. But if for whatever reason you have one on your security key that you know about or on your phone, you could click sign in options and then pick another device. But this default experience is very tailored to what the client, again, thinks is the best for the user. Now, if we were to add an allow list for a reauth scenario, you'll notice it will jump directly to the biometric prompt because the local client has that credential, and the only option is to use that credential in that provider and do a biometric prompt. So it's a very, very, much more tailored experience depending on the flow. And the last one, you'll see the difference in the user experience for passkeys on a security key. Right, so you'll see most clients will jump directly to these screens. They slightly vary, but they all kind of say the same thing. If I were to provide an allow list with only USB, a credential ID with only USB as the transport, right? There's no point in asking the user to go through a selection screen and then they get to a place where they're going to fail, right? Take them directly to the point where they can be successful, and the only option here would be plug in your security key. So after the allow list, we jump to local passkeys. Just a term I gave it, right? There's no formal term for this, but essentially passkeys that are available locally on the device. The first thing that typically happens, if the WebAuthn client, again, let's use Chrome as the example, has a built-in provider, Chrome does, Google Password Manager, it's going to first check the built-in passkey provider. Like, do you have any passkeys in Google Password Manager available, right? If so, add them to the list. But it also may go query off to the platform, right? So there's kind of a line between the OS platform and the client. The WebAuthn client, Chrome, will go query, hey, underlying platform, do you have any passkeys as well, right? Could be Windows Hello, could be iCloud Keychain. And then that entity will then go query other passkey providers, right? So it's kind of this branching logic. Now this is an example of collapsing this down. Some of those platform APIs pre-fetch all of the credentials, some ask independently. All of that detail is platform specific, but ultimately the goal is tell me about all the passkeys that can be used. And the WebAuthn client will then aggregate them together to show an awesome, fairly user-friendly, I think, list of which credentials are available. Shout out to my favorite WebAuthn people in this dialogue. Akshay's not here, but sorry, Bub. I should have put you in here. So here's an example, right? A passkey. So these are ultimately representing different accounts. So I have an account on WebAuthn.io for Akshay as the username, and also for Tim. Akshay is from Windows Hello. Tim is from Google Password Manager. Same thing over here. This is a modal UI, button UI. Same thing. I have an account for Matt, but that's an iCloud Keychain. And I have Tim in Google Password Manager. Right? So that's the result of going out and fetching all of these different credentials from the different providers on the client. Now, if there are no local credentials, it's going to default to external authenticators. The client will only show this screen, this next screen. I'll go back. Select one from a security key, select one from your phone. It varies a little bit by platform, but it more or less tells you the same story. So, authenticator selection scoped down to external authenticators only in that context. So that's kind of the last step, right? If all else fails, the user might have one on another device. And that's, in consumer scenarios, not the best, right? Hopefully we'll never get to the point where a user is seeing that regularly as the ecosystem evolves, right? Google Password Manager will now sync to desktop, right? We're starting to even out some of those uneven areas in the ecosystem. But in enterprise, right, that might be the desired state, is going directly to security key selection. What about browser extensions? My favorite topic, if you know me. Well, passkey providers running as browser extensions are WebAuthn clients running inside WebAuthn clients. And Nick walked in. Look at that. Hi, Nick. This sucks. But it's a reality because of the ecosystem, right? So I will acknowledge that as much as you all hear me complain about this. It is a reality. And what's slowly happening, right, is the ability for these third-party providers to plug in natively. That's not to say they will ever be completely removed from browser extension models, but it's not something I personally would like to strive for in the ecosystem. I would love everyone to plug in and be able to show up in that nicely painted UI and not have fighting UIs and all these other things, right? But I do think browser extensions, the vendors building the browser extension are doing a great job at trying to adapt to these conflicting experiences. So kudos to you all for dealing with all that. Some quick takeaways, since we're already at time. To think I was going to do an hour and a half. Open ecosystems are complex with many components, right? Everything we're seeing here is with the goal of having an open ecosystem where anyone can be a passkey provider and the user can choose what they want. That comes with complexity. Closed ecosystems are super easy, right? Because you have full control. Open ecosystems are hard. WebAuthn clients are really smart, and they will use all the available context they have, most of which will never be visible to you as a relying party, right? It's local device context, for example, to guide the user through the best experience, while hopefully, right, the end goal should be that you as a relying party don't need to worry about all that much to get a successful authentication. We're not there yet. We're getting there. We're close. Things are really starting to, compared to last year this time at Authenticate, right, the experiences are really starting to come together. They're changing. They're adapting. The WebAuthn clients are constantly tweaking UIs, right? It's funny, there's always a lot of feedback like, oh, this UI changed, but it's usually based on a ton of user research and complaints from users, relying parties to find a happy medium in the middle. What we didn't talk about today, this was like the whole piece that got slashed, in addition to talking deeper about registration, is the app platform. So hopefully if you found this informative, I can talk about what the differences are in the native APIs and how the app platform is a WebAuthn client maybe next year, same time, same place. So 3 minutes left. We can do some questions.
So the way we're going to do Q&A is we got this nice mic stand up here. Please feel free to come on up and stand in line.
Someone asked if I named the session Onions because passkeys make people cry. No, that's not why I did that.
I have a question. It's not exactly like what you're talking, but I need some thoughts to be run by. You talked about like a browser extension where a web client running inside another web client, right? For example, if you have an identity provider which is not supporting passkeys, or let's not even go to passkeys. Let's talk about security keys. Not supporting security keys. But there's another plugin where another product can support security keys. So how do you try to see that in terms of, and I had to come in and then plug in to be able to use the chained IDP or chained security key provider as an authenticator into the main IDP? How do you?
Yeah, I mean, I think, and the passkey providers in the room, please feel free to enter as well. The guidance has been like, if you don't understand something that's coming in, pass it, like just fall back to the platform who probably supports everything, probably. So that's kind of been the guidance, right? So like if, for example, if you send hints for security key, a passkey provider running as a browser extension may not even offer to answer it, right? So that's I think the best we can do because it's an open ecosystem. In a closed ecosystem, you can put policy around it and say you will not be accepted. It's not the world we want to live in because then you stifle innovation, right?
Okay.
So that it is, luckily, a lot of the passkey providers are participating in these discussions, right? So yeah.
Hey, got a question from online. Are passkeys multi-factor, or should you still be doing email verification for like a second factor auth after passkeys, which in that case may only be single factor auth?
This session is about how the WebAuthn client works. I'm not answering that, sorry. Nice try, Dean.
Okay, so you talked about hints, right? A lot of times, like, how do you manage the scenario where you want to say, like, okay, you don't have a passkey versus, like, showing them a security key or another remote provider? Because, like, clients can make mistakes, right? Like, they can set incorrect hints. So, like, as a platform like, what's the stance that you take? Do you always show them, like, hey, there is this other place where you might find a passkey, or, like, okay, you should try something else?
Yeah, I think you'll find in at least 2 major WebAuthn clients, They're in the room. They often provide a dump out to the selection screen regardless of what you send in the selection, right? Which I think is actually a good pattern. Right, the goal is to make sure the thing that's first for the user that they're ultimately going to get confused on or not makes sense, right? So I think providing another way, or the terminology like use a different device, I think that's the best way to handle both use cases so the user can get unblocked if they need to. It's a little bit interesting in the spec, right? Because the spec does say if you're cross-platform, do not ever show a platform option. There's room for interpretation there.
Also, like with the new hint spec, right? It's supposed to, just like it's as it is defined, it's a list, but you only just see like the first option. Like, what's the why is it a list?
Yeah. So again, the reason it's called hints is because it's only a hint, right? The client is still going to do what it thinks is best for the user, right? For example, if you send cross-device, or you send hybrid, right, which enables cross-device, and the client doesn't support it, they're not going to show it, right? So that's why it's a list. So you can do order of preference.
Thank you.
And I think we are at time.
Yeah, that's going to do it for Tim's session. Thank you, everyone, for coming on out. Thank you, Tim, for the excellent presentation. And we'll see you back in 5 minutes for the next talk.
And now I get to introduce Matt. You should stay for Matt's session.